name is Amanda Quirk. I'm in the Astronomy and Astrophysics PhD program, and the title of my talk today is A Tale of Two Galaxies, Studying How Galaxies Change Over Time. If we were to truly study a galaxy's life, we would need billions of years. Now that is way longer than I planned on spending in graduate school. So to study how a galaxy forms and changes over time, astronomers, like me, have to act more like archaeologists. We look for evidence that represent a tiny snapshot into a galaxy's life. Now, a lot can happen in billions of years to a galaxy. There are violent bursts of star formation, energetic deaths of massive stars, and galaxy collisions. I'm particularly interested in those collisions, called galaxy mergers or galactic cannibalism. Mergers tear apart smaller galaxies while feeding larger ones. They can completely change the way a galaxy looks and behaves, so they are a critical part of a galaxy's evolution. I look for signs of mergers in two neighboring galaxies, Andromeda and Triangulum. To study these galaxies, I use one of the largest telescopes on Earth to observe stars in them. You see, the thing about stars is they're gossips. They give away many of their secrets just through their light. With cutting-edge technology, we can measure how quickly a star is moving from millions of light years away. I leverage this to compare how quickly young and old stars are flying through a galaxy. If there's a difference, we know that something must have happened to that galaxy between the time that the old and the young stars were born. And that something could be a merger. Using this technique, I found that the Andromeda galaxy likely had a major merger in the past 4 billion years. This is relatively recent and unexpected. It actually changes what we know about the types of mergers spiral galaxies can survive. It also calls into question its interaction history with its smaller neighbor Triangulum. So I've been observing stars in Triangulum for the past 4 years now. And I've found that Triangulum has a very different history from its larger neighbor. The young and the old stars are moving similarly, and they don't show many signs of disturbances. This suggests that so far, Triangulum has been left alone by Andromeda and by other smaller galaxies that have passed by recently. But it won't stay that way forever. Triangulum will collide with Andromeda in billions of years. And it's actually not the only one. The Milky Way, our own galaxy, is also on a crash course to colliding with Andromeda in the far future. So the work I'm doing today actually informs us about the future of our own galactic home. Thank you.